Hello and welcome. In this video, we are going to do a quick input and output mapping to match our PLC program to the Bakersfield College test stations that we have. So you can see that some of these addresses don't line up perfectly. We have inputs are referenced without the slot number. So we can see for this first input here, we have I0, so it's missing the slot number. And the reason for that is that slots can change. The cards can change their position in the backplane, and that would change the slot number. So we have to convert that to the proper slot number within the program. So I've done my read IO configuration, and you can see that I have the PLC in the 0 slot. I have the IB16 16 input sync card in the 1 slot, and I have the OB16 16 output card in the 2 slot. All right, so first I'll add a open set of contacts, and that's going to represent our input 0, which is normally open, NO for normally open. So in Allen Bradley, normally open translates to examine if closed. And we're going to use the 1 slot card channel 0 to reference that. And we'll call this upper blue push button. For our output, we have a light that's going to be referenced by the output slot, which is slot 2. And for an output, we're going to add a OTE, which is an output to energize. And so when this rung is true, that light will turn on. So to reference that, we are going to use channel 0 of the output card. And remember, the output card is in slot 2. So we'll call this upper blue LED. And for the symbol, we'll just do U_blue LED. Okay, so now that I have my first reference for my first input and first output, I'm going to just copy this 8 times for every light combination that we have. So we have rungs 0 through 7, 8 rungs, and I'm just going to go through and update these addresses to match the addresses that I have on my test stations. So channel 1 is going to be a upper green push button, and we'll call that U green PB. And then we'll do the same thing with our output address. So that's going to be channel 1 of the output card, which is O2/1. And we'll call this upper green LED. And we'll call this U green LED. All right, we'll just continue with the rest of these. We'll call the upper yellow push button upper yellow PB and U yellow PB for the symbol. We'll do the same thing on our output, so that's going to increase by 1, which will be channel 2 of our output card. And this is going to be upper yellow LED. And following the same convention, we will do U_yellow_LED. All right, our next one is a little bit of a trick because we have a normally closed set of contacts instead of normally open. So we're just going to change this instruction type to examine if open, and we'll increase the address by 1. This is channel 3 of the input card, and this is going to be our upper red push button, U_red PB. We'll do the same thing on our output. So this will be output slot 2 channel 3, and this is going to be upper red LED, U red LED for the symbol. And we'll just keep going through the rest of these. Call this lower blue push button. We'll call this lower blue LED. Our next one will be channel 5, which is going to be our lower green push button. We'll call that L green PB. And then we'll increase our output address by 1. So it'll be channel 5 of our output card. So again, channel 5, and our output card is in slot 2. So this will be our lower green LED, L green LED. We'll increase this next one to channel 6, and this is going to be our lower yellow push button. And then our output will be channel 6 of the output card, which is going to be our lower yellow LED. And then the next one is also a normally closed set of contacts on channel 7. So we're going to change the instruction type to XIO, and we're going to increase the address to channel 7 of our input card. And this is going to be our lower red push button. And we're going to change our output to channel 7, which is going to be our lower red LED. Okay, so that covers all of our push button and LED combos. Now what we have left is our e-stop. We have our single pole, single throw switches, and we have our output motors, and we also have a siren. So I will go ahead and add those. And first we're going to do the e-stop, which is a normally closed contact. And this is channel 15. So that'll be input slot 1, channel 15. We'll call this e-stop and then ESD for the symbol. And then we'll just tie that to one of the motors. So the first motor is channel 14 of the output card, which is going to be slot 2, channel 14. We'll call this motor 1 and MTR_1 for the symbol. Next, we'll add some of our single pole, single throw switches. So the first one is channel 8 of our input card, which is going to be slot 1, input 8. And we'll call this switch 1 and SW_1. Then we'll add a branch just to put all of these switches together. Since they're common, we can extend our branch down for all 4 branches. So we'll add the next input, which is going to be the input card, which is slot 1, and that's channel 9. This will be switch 2. We'll call this SW_2. And then we're going to do the same thing for switch 3. And for those, I'll go ahead and tie those to the siren. And the siren is channel 8 of our output card. So again, slot 2, channel 8. We'll call this siren and SRN for the symbol. So now the way this logic will work is if any of the single pole, single throw switches are turned on, our siren will also turn on. And then for our last one, I'm just going to add an internal bit, which is going to be our B3 word. So I'll use the first bit, and this is just going to be an arbitrary start command for motor 2. So we'll call it MTR2 start command. And for the output on this run, we're going to address that to our second motor, which is output 15 of our output card. So again, slot 2 for the output card, channel 15. This is motor 2. We'll call this MTR2 to match the convention of motor 1. And so now we have all of our push buttons that are addressed on rung 0 through 7. Then we have our emergency stop that is on rung 8. Tied to motor 1, which is also on rung 8. So when the e-stop is not pressed, motor 1 will be running. When it's pressed, motor 1 will stop. And then we have a OR circuit for our siren, so that if any of the single pole, single throw switches are turned on, our siren will energize and hopefully produce a sound. And then lastly, we have an internal bit tied to B300. When that's toggled, motor 2 will turn on and spin. So we'll go ahead and verify this program, make sure we are free of errors. Everything looks good. So now I'm going to save this project, and we'll just call this test station. And we're going to go online with the download. Okay, so by default, we go into this remote program mode. We want to be in run mode, so we'll switch that by selecting run from the dropdown. And right off the bat, we can see that our motor 1 is running. And that's to be expected because our e-stop is currently not active. So if we push that and deactivate the emergency stop, that circuit opens and motor 1 stops. The next thing we would expect to do is when we press each one of these buttons, we expect the corresponding light to turn on. And so input 0 of the input card is tied to the blue upper push button, which is energizing channel 0 of the output card, which is the blue LED. So if we just go through each one of these, they should correspond with the input and output configuration in the program. Next, we want to test our siren with our single pole, single throw switches. So we'll do the first one on channel 8, our siren is on. Second one, channel 9, siren is on. Third, channel 10, siren is on. And fourth, channel 11, siren is on. And then lastly, we have this internal bit, B300. We can toggle that bit and that turns on motor number 2. Thank you for watching, and I hope this helps.